Here we're given some parametric equations. We'd like to graph the curve that's represented by those equations and then find the corresponding rectangular equation. We're given the parametric equations x equals 3t minus 2, y equals 1 minus the square root of t. And we're going to do this for values for t that are between 0 and 9 inclusive. To plot the graph, we would need to make a table of values. We're going to go ahead and just set up a little table here. Values for t, and then it'll give us values for x and y. And then we'll be able to get a point x comma y from that. We're going to pick some values for t, keeping in mind our restriction here that t has got to be between 0 and 9. So we'll let t equal 0. If t is 0, x is negative 2, and y is equal to 1. So we would get the corresponding rectangular point, negative 2 and 1. If t is 1, we'd get 3 minus 2, or 1 for x. We'd get 1 minus 1, which is 0 for y. And that gives us the point 1 comma 0. If t is equal to 4, we'd get 12 minus 2, which is 10 for x. And then 1 minus 2, which is negative 1 for y. So we'll have the point 10 comma negative 1. And then we'll do one more. We'll let t equal to 9. If t is 9, we'll get 25 for x, and we'll get negative 2 for y. So we have the point 25 and negative 2. We're going to go ahead and sketch the graph of this equation. Remember that we have x is equal to 3t minus 2, y is equal to 1 minus the square root of t. Those were our parametric equations. We were plotting the points, negative 2, 1. We're going to check our scale here. Each tick mark on the x-axis represents 5 units. Each tick mark on the y-axis represents 1 unit. So the point negative 2, 1 is going to be roughly there. And that corresponds to t equal to 0. We're going to plot the point 1 comma 0. 1 comma 0 is going to be right about there. And that corresponds to t equal to 1. Then we plot the point 10 comma negative 1. So we have 10, negative 1. And that corresponds to the value t equal to 4. And then lastly, we're going to plot the point 25, negative 2. So go to 25, go down negative 2, and that corresponds to t is equal to 9. We're going to sketch our graph. I'm going to start here at our first point and draw a curve connecting the points. Remember, we only let t go from 0 to 9, so that's the complete graph. We also need to show the orientation for these parametric curves. The orientation will be in this direction. As t increases, the graph is going this direction. And so there's the graph of our curve. The next thing we need to do is find the rectangular equation for this curve. To do that, we need to eliminate the variable t from our equation. We're going to start by solving this first equation for t. So we're going to have x plus 2 is equal to 3t, which will give us that t is equal to x plus 2 divided by 3. If we substitute this result for t into our second equation, we'll get that y is equal to 1 minus the square root of x plus 2 divided by 3. And we were given a restriction on the values for t, so we also need to put a restriction on our values for x. We'll have that x has to be between negative 2 and 25. We can actually see that from our graph here. So this is our rectangular equation for the corresponding parametric equations. Now that we've graphed the parametric equations by hand, let's graph the parametric equations using a graphing utility on our Smartboard interactive whiteboard. We want to graph the curve whose parametric equations are x equal to 3t minus 2 and y equal to 1 minus the square root of t. We're going to do that for t between 0 and 9. If we go to our graphing calculator, first thing we need to do is change the mode. Typically we're in function mode, but to graph these parametric equations we want to be in parametric mode. So we'll hit our mode button and we notice that in the fourth line, it's under func, which is for function. We want to be under parametric mode, so we're going to change that to the second option. So move down there, move the cursor so it's highlighting the parametric mode, and hit enter to select that. We're going to go to our y equal to screen to actually enter our equations. Notice our y equal to screen looks a little bit different now. We're going to enter the x in terms of t. So we had x was 3t minus 2. And notice here we use the same variable button that we did before with x, but once we change the parametric mode, it now represents t. So x is 3t minus 2. We hit enter. We enter y, which was 1 minus the square root of t. And then we will scroll down, hit graph. Now our graph of our parametric equations is kind of squashed here, so we want to adjust our window settings again. If we hit our window button, notice this is slightly different than we've seen before too. We need a t-min and a t-max. Remember we were going from t between 0 and 9. So t-min of 0 is fine. Just hit 0 again. T-max we want to be 9. And t-step go by 1. And hit graph again. Again, it's still a little bit squashed, so we're going to change our x and y values to get rid of a lot of this white space. It looks like we don't need to go much past -2 for x min. We can go out a little bit past 10 just to make sure we see the complete graph. So we'll let x max be something like 15. And for the y min, we might cut that down to, say, -3 and then go up to +3. So we go to our window. We've already adjusted t. We're going to let x min be -3. X max, we said we're going to go up to 15. We'll go ahead and leave that scale at 1. Y min, maybe -3. Y max, +3. And again, we'll scale by 1. Go ahead and graph that. And get a little bit better view. Now we want to make sure again that we're seeing the complete graph. We don't want to go t past 9. So let's increase our x max, maybe 20. And let's scale by 2 this time. Graph that. Still not quite seeing the end of the graph. Now we can think about this. Our t max was 9. We go back to our parametric equation for x. If we let t equal 9, 9 times 3 is 27. 27 minus 2 is 25. So we could have gone right there to see what our bounds on our window should be. So we need to go at least to 25. So let's change that to 30. Go by scale of 2 still. And hit graph again. And we notice here that the graph actually stops, because that's the furthest we go when t is equal to 9. So here we see our complete graph. And we also want to see the orientation of the graph. Now it's fairly clear when we first graph it that it's going to start up here and move down. But if we go into our y equal to menu and scroll over to the left, so we highlight the type of graph that we're going to use. Instead of the solid line, let's change that. We'll hit enter. Oops, a little too far. Thick line. We're going to change it until we see the little bubble. This is going to be in our trace mode, so as it graphs it, you can see the little bubble trace through, and it kind of helps us see the orientation better. So hit graph again, and we can kind of see the orientation of our graph as it scrolls through t from 0 to 9.